All right, so welcome. We're going to be talking today about the use of AI in producing evidence for evidence-based decision-making in healthcare, and really focusing on responsible uses of AI in the integration of systematic reviews. So just to give you a sense of what we're going to cover today. We're going to talk a little bit about systematic reviews. Not sure how much experience the folks on the call have had with conducting systematic review, but we want to sort of set the stage for the type of review that we're talking about in today's webinar, why AI might be useful in this context, and then talking a little bit about how AI can help in different steps of the evidence synthesis or systematic review process. We're really going to focus most of today's webinar on large language models or generative AI, and in particular, the use of large language models for the screening and data extraction steps of systematic review. We're going to show a bunch of what I have found to be very useful emerging research on this topic, as well as point you to current best practices and guidance for how to integrate AI into your systematic review workflows. And now we're going to wrap up with a little bit about how SysRev, our software, can help you carry out these kinds of workflows with AI in your systematic review using these best practices that are recommended. So first, just a little bit about systematic review. If you're not familiar, this is a very structured type of literature review that aims to gather all of the possible evidence about a very specific question, and the evidence is then usually combined in a meta-analysis to arrive at some broader conclusion about what works or what doesn't work for, say, a given population. The steps in systematic review are very well defined. It starts with clearly defining a research question, defining criteria for how you are going to select which studies are included in your review, using those criteria to then screen studies after comprehensively searching across multiple databases, identifying the included studies based on those criteria, and then going about a systematic process of extracting information from each of the included studies in your review to then analyze in meta-analysis or some sort of other synthesis approach. There's a lot of other types of structured literature reviews that use these methods or some part of these methods, things like scoping reviews, systematic maps, and other types of review processes. And so a lot of what we talk about today actually will be applicable to those other kinds of reviews as well. So why do we need to be thinking about AI in systematic review? We know that systematic reviews, which are commonly used to make decisions about things like patient care, need to be rigorous, transparent, and as comprehensive as possible. And yet we are facing just overwhelming volumes of research. Whenever I, as a librarian, do my systematic searches for systematic reviews, inevitably I'm coming up with thousands of results that the researchers I collaborate with then need to screen. So this is just becoming basically unsustainable, and we need to really turn to current technologies to help us be more efficient and to get this evidence out into decision makers' hands more quickly. So AI can help in many steps of the review process. AI is really just a way to automate tasks that humans would normally do. So there's lots of different ways that AI can support things like searching for studies, screening for studies, deduplicating studies across database searches, extracting information, and really any other phase of the review process. But we really need to think about how to do this responsibly and in a way that's not compromising the rigor of the systematic review. So one question we need to think about is how much AI do we use? How much do we depend on AI in this process? Do we use the AI to replace what the humans are doing or to really just assist what humans and human expertise does in this process? So I do want to make the point that AI has been a part of evidence synthesis for decades. So thinking about AI in the broader context of what that means, there are sort of more rudimentary rules-based approaches in artificial intelligence that are commonly used in the way we search for studies, for example. So Boolean searching could be considered a form of AI. The way we deduplicate studies across database searches is essentially a form of AI, a form of automation. Um, Machine learning has been used for quite some time now in helping folks screen for studies and determine what studies are eligible. I'll talk a bit about that in a couple of slides. And then more recently, we have advanced natural language processing and neural networks and other approaches that have really sort of improved our ability to use AI in things like data extraction. But of course, in the past couple of years, we have the emergence of generative AI or large language models. And this really, really changes the way we can think about how quickly or how scalable or even just the versatility of the way that we apply AI in systematic review. So this is very sort of game changing, I think, for thinking about automation and semi-automation of systematic review. And we'll be focusing much of the talk on generative AI and large language models. But before we get to that, I do want to just say that machine learning is routinely used in artificial or in systematic review. So if any of you on the call have done systematic review using some sort of software to support that process, there's a good chance that software has used some kind of machine learning to help you speed up the screening process. The way this is typically done is that as humans make decisions about whether or not articles should be included, a machine learning model is being trained in the background based on those decisions, and then often used to sort records based on records that are, or articles that are thought to be, or predicted to be more likely to be included based on those human screening decisions. And this can be used to just speed up the screening process. So you're sort of quickly working your way through things that are most likely to be included and then coming to many records that have been sorted as less likely to be included. That said, there's actually quite a bit of evidence to suggest that a well-trained machine learning model could be used to just bulk exclude a lot of records after enough human decisions have been made. There is quite a bit of debate around how we determine when to stop screening or when that model is sufficiently trained, or when we've reached a point where we can be confident that the rest of the records in our list are irrelevant. And just to sort of, if you're interested in kind of understanding what the options are in terms of determining when to stop screening in this prioritized screening context, this is a really nice review article that just discusses a lot of the different methods for determining when to stop screening. Okay, I'm going to go ahead and turn, I think, most of the rest of this talk over to large language models because this is where most of the focus is currently. This is a really nice living systematic review that was recently updated on data extraction methods and semi-automation or automation of data extraction for reviews in clinical medicine. And what we can see from this really interesting chart is that large language models have already become largely the focus of the most recent research on how do we automate and semi-automate data extraction. So these are all of the different artificial intelligence methods and automation methods that have been used and studied for systematic review. But you can see the most recent years of research really focusing on large language models. And I think we'll see this bar overtaking a lot of these other methods in the not so distant future. This is also a really nice recent scoping review on the research about large language models and how they can be applied in different steps of systematic review. This is part of this process, or this review was to look at the research and as well as how promising those research studies showed large language models were for these different steps. And I just want to call your attention in this chart to a couple of different squares here. This bottom row is the non-promising research. So these are the research studies that found large language models weren't very good at these steps. And you can see there's a cluster here in the searching step. And so, in fact, it's been shown in numerous studies that generative AI and large language models are just not good at writing a search strategy that is sufficiently comprehensive and rigorous for systematic review. As a librarian, that's good news for me. My expertise is still important and needed. We do, as librarians, use large language models quite a bit in the way we construct our searches, but really, you need human expertise to make the decisions about how to construct a comprehensive search, when to stem terms, how to effectively use things like subject headings in different databases, and LLMs just aren't quite there yet. So I just wanted to point that out. However, in this top row, which is the promising studies, we actually see quite a bit of promising research showing LLMs could be used for screening, and also quite a bit for data extraction. And so that's where I'm going to focus most of the talk today. Just to sort of drive home the point that for searching, we really still probably mostly need to rely on just sort of our standard traditional methods of searching databases. You will find there are numerous and every day seemingly more software tools or websites that claim to allow you to do systematic reviews and include a way of searching and identifying relevant studies for your review. However, I would caution against those. Those kind of tools often use ranking algorithms that are just kind of a black box. We don't know how they are deciding what is relevant and what isn't relevant. They're not allowing researchers to use their own expertise to make those decisions. And more than likely also exacerbating different kinds of publication biases, which is something that we're actively trying to avoid in doing a systematic review. So caution against using tools that have these built-in search features and continuing to do, work with a librarian, work with an information specialist, and do these robust searches across many database sources, and then bring them into the software that you're going to use for screening. Like I said, large language models can be used to support developing search strategies. For example, term harvesting or just finding potential relevant terms to add to your search. I often will use LLMs to help me adapt my searches from one database syntax to another, although always checking all of that translation because often there are errors there. I also use LLMs to find studies that might be relevant to my review that I can use to test the comprehensiveness of my search. So just a few ways that generative AI can be used for search strategy. I do just want to drive home the point, human experts for searches really should always have the final say in what that search strategy looks like. Okay. So in terms of screening, the way folks have been using large language models to support the screening step of the review, this is where you're deciding from a whole lot of results that you got from databases, which of those studies are relevant and irrelevant. And usually folks are just constructing a single prompt that sets the context for the review, describes the criteria for selection, and then provides the LLM very clear instructions about what to do with that criteria, how to make a yes decision or a no decision about an article. What can be done here is that you can take a lot of records that humans have already screened. A really good use case for this is when you're updating an existing systematic review, or maybe you're doing the supplementary search steps like citation searching at the end of a review process. and you have a bunch of articles where you already have human decisions. And you can use those human decisions to really test and validate a prompt to the point where you can achieve some kind of threshold of accuracy. And that threshold would be determined by your own review context and what level of tolerance you might have for missing studies. And you can test and validate to the degree that you can then apply this on, say, an update of your searches. And this can be a really great way to use LLMs in this workflow, potentially saving quite a bit of screening time. A really nice example of this is this recent study by Homiar et al. That used large language models to screen titles and abstracts in a living review. This was done on a living review of dopamine interventions for anhedonia. And they were able to use, in this case, GPT-4o, to develop and test a large language model prompt achieving 100% recall against human decisions. So they were able to develop a prompt that found all of the relevant records that the humans had found in the initial screening. Once that was tested, validated, they were able to apply this to the update of their living review. You can see that they applied it to well over 12,000 records and 2 updates, and a pretty significant workload saving. Just want to make a point here. It's really important to think about the articles that you might have in your search results that might have missing abstracts or even short abstracts. And this is a scenario where a large language model just won't have enough information to make a good decision. And so generally speaking, you're going to want to remove those and go ahead and manually screen those records. Okay. Yeah, and I'm going to pause here to just say feel free to put questions in the chat if you have them. Happy to answer those as we go along as well. Okay, so for data extraction, because data extraction is just much more complex, it would be pretty unfeasible to have a sufficient sort of test and validation data set to fully validate prompts where you could like turn this over entirely to AI. The approach here is really more an AI assisted approach as opposed to just an AI only approach. So in this case, for data extraction, the recommendation is you spend a bit of time designing prompts. You have the AI extract the data from the studies that you are reviewing, but then you have a second reviewer, in this case, a human, actually going through and checking the accuracy and completeness of that extracted data. One word of caution here, this is where you might run into hallucinations or just false, incorrect information being extracted. This is especially going to be a problem when you might have missing information, so information that just isn't present in an article. So this is just something to be aware of here. Great example of using data extraction in this AI-assisted approach is this paper. Again, recent study. In this case, they actually looked at, sort of compared 2 different approaches across 6 different systematic reviews in different healthcare interventions. In the first team, they had just sort of the traditional human-human extraction approach. And in the second team, they did this AI human extraction approach and did a sort of direct comparison of time savings and accuracy. They used Claude Pro in this case, and across these 6 systematic reviews, extracted over 9,000 data elements from 63 studies. And in fact, they found that the AI-assisted approach was actually more accurate than the human-human approach. This human data extraction process we know is quite error-prone, and this study at least tells us that AI might actually help actually improve accuracy, which is really interesting. They also found a pretty significant time savings per study. So I think the evidence is starting to emerge that, in fact, LLMs can be used to support both screening and data extraction in ways that save a lot of time, get the evidence into decision makers' hands more quickly, and even possibly improve accuracy. So you might be wondering if there's any existing guidance available to help do this, again, in a responsible, transparent way. And in fact, there's some recent guidance documents that have been published, and these are on the Open Science Framework. This is a three-part, three-document set of guidance, and I'm going to call your attention in particular to RAISE 2. So this is Responsible AI and Evidence Synthesis, Building and Evaluating AI Evidence Synthesis Tools. One thing to note, this guidance is about AI broadly, not just large language models, but they do have some large language model specific guidance in these documents. And it's interesting when they talk here about AI evidence synthesis tools, they include in that the idea of building a prompt, right? So if you're designing a prompt to help you screen records for a review, you're essentially building an AI evidence synthesis tool. So the guidance here can really be helpful in doing that sort of thing, again, in a way that's responsible, transparent, and mitigating potential impacts to rigor. A few highlights I want to call your attention to in this document. When you do develop prompts and you're doing sort of a testing and validation approach, you want to ensure that there's no overlap between your test set and your validation set. I already mentioned the issue with hallucinations, but another thing to consider is consistency. So running the same prompt on the same records multiple times to see how consistent the LLM is in its answers. That's just another important measure to consider when understanding how well this is working for your review. Another thing that comes up in these studies is the idea of data contamination. So this is where the model that you're using was potentially trained on partially trained on the data sets that you're using to do testing and validation, which is not ideal. So you can imagine a scenario where you might be using a data set from a published review that was published a few years ago. It could be that the model you're using, such as GPT or Gemini, in its training data actually has that systematic review. And so you want to avoid that kind of situation. You can do that by using data sets that aren't published or that at least aren't published in open access format. And just keeping that in mind as you're going through this kind of validation process. These documents also have great guidance on how to report the use of AI and how to report the performance of your LLM tool, the different performance metrics that you should consider, the data sets that were used, information about the model that was used, and the intended use of that tool that you're building or that prompt that you're building. Okay, so there's so much more to talk about in the context of all of this. One of those things is prompt design, and right, you could spend definitely a whole hour talking about different techniques for designing prompts. There's certainly best practices that I think have emerged, things like context setting, sort of setting up the context for what you're asking the LLM to do, just clear instructions. But there's also a lot of different techniques, like zero versus few shot. This is where we either give examples or we don't give examples of, for example, included or excluded studies. Incorporating reasoning approaches, so asking the LLM to sort of reason through its process. These can very much change the outcome of the LLM's answers. And so I think this is still a developing area and trying to understand which of these approaches might work better in the context of screening or data extraction. But these are things to sort of think about as you're building your prompts for these kinds of workflows. these are two papers that I have found quite useful in understanding the different methods and techniques and again, sort of their application in the context of systematic review. Another kind of more practical consideration is just how do you do this, right? Like how do you actually go about using LLMs in the context of your review? Um, there's a lot of different things to consider here. I mean, there are cases where folks are using the chatbot user interface directly, uploading maybe a PDF or a group of PDFs at a time. This can be a bit, obviously with screening thousands of studies, that would be pretty unfeasible. So another option is directly using the generative AI API in a programming environment. This is much more streamlined, but you do need to know how to work with APIs and how to work with programming languages. Um, the alternative is considering a built for purpose tool, and SysRev is one of those tools, and we'll show you what that looks like in a moment. A few words about SysRev. Specifically, this is a software designed for screening and data extraction, systematic review. Um, Unlike other tools out there, it's highly flexible. So whatever workflow that you might decide to use for your review, SysRev can support. It is also discipline agnostic. So assuming many of you work in the health sciences, some folks viewing the webinar might be in different disciplines. There's nothing about SysRev that would prevent anyone from any discipline using it across in a given disciplinary setting. We have folks using SysRev in many, many different disciplines. You can import any documents into SysRev. It's very flexible in that way. And then there is what is called the auto labeler. This is the large language model feature where you can design and test prompts in the app against human screen studies. You can do this human in the loop workflow that I showed you earlier. And then there's two different model choices at this time, GPT-4o and Gemini, that you can test to see which one works better for your review. So with that, pause for questions. Feel free to, you can feel free to unmute yourself or to throw something in chat. It's a lot of information. We'll go ahead and send these slides along. B, I think I see you unmuted yourself, but I can't hear anything. Feel free to type something into chat.
Hi, can you hear me?
Yeah, there's a bit of an echo, but you can give it a try.
Is it better?
Yes.
Right. Thank you very much. It's quite interesting because I'm a systematic reviewer, very interested in knowledge synthesis, and sometimes it's frustrating, really, having to navigate through the papers and all the 9 yards of conducting systematic review. And so it was quite interesting when I saw this, and I wanted to join. A few questions. So I heard you mention a number of things, and I want to find out how ethical, is the process. Because I think the use of AI for us researchers, that is the burden. Because at the end of the day, you would want to publish the work, and then it's picked up. Plagiarism, AI has been used, and all that. How does it work? What do you have to say regarding that? Can I use AI, or as you are calling it, LLMs, and conduct my review and submit for publication without any hurdles?
Well, that's a great question. And I think there's a lot of ways that you can use LLMs that would not be responsible or ethical, and ways that you can use it ethically and responsibly. And so I think part of sort of the responsible use of AI is transparency. So just being very clear on how and when, where the AI contributed to the review. That's absolutely key. Um, And I think probably a requirement of a lot of journals at this point in terms of just even like, was it used to support the writing, anything of that sort. When it comes to using LLMs in screening, data extraction, sort of, choosing relevant studies for the review or helping in any kind of way in the analysis part, that's where I think it's still a little bit unclear how and when that can be done without compromising the quality and rigor of the review. But I do think I would definitely suggest looking at these documents. This is what I think is probably the most current and robust guidance that we have at the moment on how to use AI in systematic review. Um, these are, for me, these have been just reading through these documents have been really helpful in understanding just the practical considerations of doing this and doing it responsibly. So hopefully that's a useful reference for you. And yeah, hopefully that answered a little bit of your question.
May I add on that?
Yeah, please.
Um, Two different points, same perspective. So something that Sarah didn't quite address there, but I think was kind of implicit in your question is how do the publishers feel about this being done on their quote unquote content? Not necessarily using it to write the paper, but using it on existing papers in our conversations with publishers. So for folks who are less familiar with Sysrev, we actually built Sysrev back in 2014 as our own internal tool because we were looking to extract a lot of chemical data from really dense publications. And so it is a tool that we continue to use for our own research and continue to use the new features that we build, including the LLM integrations. And so from our own conversations with publishers, which do not represent the perspective of all publishers, this is just my anecdotal experience, is that they have an interesting distinction here, which is if you are using an LLM to review, screen, or extract information from one of their publications, that's okay. What you are not able to do is to use the content of their publication to train an LLM. And so, for example, within Sysrev, we have integrated with GPT-4o, we've integrated with Gemini 2.5 Flash. When we use those systems to query and, again, either screen or extract information, it's a query to that existing code base knowledge base. The LLM is not learning from the document that we are providing it, and as such, they don't see an issue with that piece. What would be an issue is if GPT or Gemini took all of, say, New England Journal of Medicine, took all of those full texts and used that information to train their LLM, which fortunately, at least for folk within the review spot or within the review space, isn't really what we're trying to do. We're trying to leverage these things that already exist to extract information as opposed to using the information to train the extractor. It's a nuance and a distinction, but it's where they seem to have drawn their lines. And at least it's good from us within the review community because it means that we're able to actually leverage these tools. The other piece that I think um, my section will go a little bit more into as well is it also just really depends on your use case. And if your intent is to write a very rigorous by the book systematic review, then at the end of the day, you're probably going to want a human to at least verify all of the information that was performed or extracted by the LLM. If your goal is to do something more scoping or to maybe inform policy or to make a strategic decision, something where 95% is good enough, then you're able to trust the AI a lot more here. We have some organizations that use Sysrev as a screening tool, and they will upload 45,000, literally, 45,000 different publications and use, we call it the Sysrev auto labeler, but our LLM integration to quickly identify the subset of articles that they're interested in. This particular chemical, this particular effect, that's what I'm looking for. They're comfortable with the idea that maybe they have some false positives, maybe, or I'm sorry, maybe they've missed some articles and maybe they've included some articles that really they wouldn't have. but at the end of the day, it still saves them a lot of time reviewing 45,000 articles. It's just non-tenable. And so again, it really comes down to what is your purpose? Obviously, with healthcare, the closer you get to patient, the closer you get to clinical decisions or societal decisions, the more important I think it is that we are more confident. And so again, there will be that human review. Um, but it really comes down to your own comfort with ambiguity, with less than 100% confidence. We try our best, we being Sysrev, to make that as clear as possible and to let the user decide what is best in each moment. But it is very much a decision.
Okay, that's fine. Thank you. I think my last question is when you were speaking about searching, you did mention a lot of LLMs, but I didn't really get to hear an exact example, that can be used at that stage. And I'll be interested to hear if there are certain examples that we could work with apart from Sysrev.
Yeah, for searching, like I said, LLMs are not, you can't just say, write me a search strategy for this systematic
Mm,
and expect that it's going to give you something that is sufficiently comprehensive or even correct. Um,
mm,
so we really aren't at a place, I think, where we can rely on LLMs for that step. Definitely recommend working with, if you have a, if you work with an information specialist or a librarian with that sort of expertise, highly recommend doing that still. Um, that said, you can use LLMs, for example, you can say, are there any search terms that I should use for, this particular concept? And there are definitely times when it will help give me search terms that I hadn't already thought of to add to my search strategy, for example. Um, there's a few other techniques that can be used that LLMs can help with. But again, I think for the searching step, we really still need to be using our kind of more traditional methods.
right. Thank you. Thank you very much.
Yeah.
And again, I would just draw the distinction between the creation of the search strategy and screening, right? And so for, again, a by the book systematic review, you really want to have the perfect search methodology that works across multiple databases, includes any terms that might be relevant. We're all familiar with this process. The one thing that LLMs do allow you to do, though, is to ask questions that help you quickly find the subset of articles most likely to be interesting to you. So instead of taking a rigorous and well thought out search strategy for something like liver disease, if you have 1,000 or more articles, you could ask the LLM which of these deal with liver disease. And so again, depending on your end use case, what it is that you're trying to do, there may still be a way for it to help you identify which articles are relevant, but it's not going to be very good at actually writing the search query that you can put into different databases and get a corpus back.
Right. Thank you.
Yeah. Yeah. Thanks for your questions. Okay. So, TJ, do you want to take it from here?
Sure. Okay. Hopefully y'all see my screen.
Yeah. Thank
Okay,
you.
perfect. Okay, so I'm going to bounce around sysrev. For the record, most of what I'm showing you applies to other solutions as well, assuming that they're able to do the same things. But this is how folks and how we use our LLM integrations in order to help us with the review process. And so I thought an interesting place to start would be with an actual publication that actually used this functionality. So this is a public project. Actually, Sarah, you know which one this is. Would you put it in the chat? So for those of you unfamiliar with Sysrev, um, it is a project-based platform. We have two types of projects, public and private. Anyone with the link to a public project is able to go to that project and see all of the information. We're quite fond of open science and open evidence synthesis, and this is kind of our way of contributing. But so what this project is it's a collection of articles that have been written and explicitly cited Sysrev as its tool. And so here I can see a bunch of labels that have been ascribed mostly by Sarah, where she's gone and looked at each article and said, what type of discipline was this study about? What type of study was it? And more interesting to what I'm trying to get to right now is how many of those actually cited Sysrev and told us which project it was. And so if I go to this article, which is on Parkinson's disease, I'm able to see that indeed we have the link for that article. It's actually quite nice, even within the PDF. Quick note, as non-members of this project, y'all would not be able to see this PDF. I'm able to because I am a member of this project. But here they actually cited the exact project that they created and where they conducted their research. And so I'm able to click that link, go to their project. It is a public project. And so if you saw the title before I clicked the link, it said that this is a scoping review, which means that they're a little bit more open to using some automated tools. Technically, they said it was a semi-automated scoping review. And so if we look at their project, we'll see that they uploaded nearly 2,600 articles, had a number of reviewers, two who actually did the brunt of the work, but they only reviewed about 875 of the articles. The reason that they only reviewed 876 of the articles is because they had the auto labeler, again, our integration with GPT-4o or Gemini 2.5 Flash, do the screening for them. And so if you read the paper, which again, the link is actually included in that, so you can go and access the article. First, they did some manual screening. Then they wrote their auto labeler prompt. This is the prompt that is used to actually query the LLM. And then they saw how it performed. And they had a few iterations of tweaking the prompt until it performed like the humans did. And then they decided to use it on everything. So let me show you how that kind of works. So again, humans only reviewed a third of the articles that are actually in this project. If we click on their articles, here are all 2,600. And if I create a filter, Sysrev is really built on filters. They're quite powerful. You can pretty much filter for anything, although it might take a little bit getting used to. What I'm doing right here is I'm filtering for auto label, for the include, and I'm just curious how often did they use the auto labeler for this particular label? And sure enough, they used it to predict for every article. That makes sense. Now, how many times did the auto labeler say, yes, you should include this article? 349. And so having used the auto labeler again on all 2,600, it found about 350 that it thought should be included. Now, if you read the paper, and they actually have an interesting description of this, they purposely made the prompt conservative, by which I mean to say they wanted it to include if there was any ambiguity, to err on the side of including too much instead of excluding too much. And so we can see this live in their data by comparing it to, well, what did the humans review? So what they ended up doing is any article that the auto labeler said that should be included was reviewed by humans as well. And so what we can do is clear out this real fast. We're going to add a quick or, where we are looking at any consensus single for inclusion, yes, because some articles were only included or were only reviewed by one person. Some were reviewed by multiple people. They have determined consensus, also yes. And so 141 articles. And so 141 of the 350 articles that the auto labeler said should be included actually were. And so again, they purposely made it include more than risk excluding articles that should have been included. But still, this saved them a substantial amount of time. Yes, they reviewed 350, but their other choice was to review 2,600. And so it's still a considerable time savings. And so this is a common way, and I would say a fairly basic way that the auto labeler is used. And so if we want to look at what did that prompt actually look like, so Sysrev allows you to create labels. These are basically the pieces of information that are being extracted. If you picture, I'm sorry, you'll quickly learn my background. If you picture a spreadsheet, right, I often think of the output of literature reviews as a spreadsheet where each article is a row and the columns are the pieces of information that you want to extract. In this world, the labels are the columns, right? I'm interested in whether or not true, false, it dealt with Parkinson's. I'm interested in what species did it look at, what level of biological organization, what they mean by this, was it a person, was it a tissue? What cell line was used, if possible, just to say lots of information that they were interested in. This include button, they had a large inclusion criteria, is what they actually use to decide whether or not an article should be included. This was both the description for the human reviewer as well as a prompt that was delivered to the LLM. Now, as Sarah alluded to, there's a lot of theory as to what makes a proper prompt. I will say quickly, the best way to know whether or not your prompt is performing well is to have some overlap between human and auto labeler. If both parties review 20 and you agree 18, 19, 20 times, it's probably a good prompt. If you only agree 5 or 10 times, it's probably not yet a good prompt. To quickly go to one of their articles, what's interesting here is they actually asked the auto labeler for more information than just include, and asked the auto labeler for more information than just what they asked the humans. And so here we can see that Veronique, I'm going to assume, just because I know where this research group is from, said that this dealt with Parkinson's, was cell-based, dealt with pesticides, included genetic data, and should be included. The auto labeler said this dealt with Parkinson's, the species was human, this was an additional piece of information. Yes, it was also the cell, it was a cell line. The study design was that it was an observational and descriptive meta-analysis, that it was a pesticide. It missed whether or not it dealt with genetics, but knew to include it and was even able to pull out the mechanism of action from this article, albeit at this stage from just the title abstract. Auto labels do also work on the full text, but for this project, they were only using them on the title and abstract. And so again, you're able to see and to use the auto labeler to pull out different pieces of information. Now, as I said earlier, one of the most important things here is that you can actually verify that the information is correct. For that, we're going to switch to demo projects because this is actually their research and I would never want to affect it, not that I could from this user account. So here's a project that I like to use where I pulled in a bunch of articles that deal with chemicals that were in the original TSCA regulations. And we're going to go to one of my favorite articles because it's just a really good visualization. So here again, we're only looking at title abstract. I created labels that asked some high-level information. What chemical is discussed in this paper? What toxicity was discussed in this paper? What species was discussed? And what was the study type? You'll notice most of the answers are the same. Some answers are slightly different. And the reason for that is because for each type of data, I actually created two different label types. So this is really easy to see with chemical. What chemical is referenced in this document? So as you can see, I actually go with very simple prompts most of the time. This is what we call a categorical label, and it means that the LLM and the user are given distinct choices. They must choose between, or they must choose one of the options that are shown here. You'll also notice that this says require answer. This is really important, particularly for the auto label. If you require the answer and you have the auto labeler process it, it will answer it, even if you don't give it the right answer. As a very simple example, if your question is color and your options are red, green, and blue, but the object is actually purple, but you require the answer and you only have red, green, or blue, it's going to choose one because it is a program and you have instructed it to. And so if you're using a categorical, we very much suggest that you use an other or a none or a not specified, some way to give the auto labeler an exit strategy. And so here is a categorical label for chemical. Here is a string label for chemical. The only difference here, the question is the same, it's still required, is that I didn't give it a list of options. Now, when we go back to the article, we can see this quite clearly shown in that for the categorical, it chose the one chemical in this article that is also on that list. But when it asked a string, it picked up every chemical that is mentioned within this article. And so again, whether or not you use a categorical or a string can really have some profound effects on what type of information is excluded, or I'm sorry, is extracted. We see the same thing for species. Species for categorical, I said bacteria. I had no choice for salmonella, and so it could not choose salmonella. Now, if you're able to read the really small text here, we do have something called reasoning with confidence, which is why you see these confidence scores in this explanation. The LLM recognizes that salmonella is a bacteria. Bacteria is one of the choices and makes the right choice. But it can't choose salmonella because it wasn't given that option. However, when asked for a string, it so can. You might be wondering, well, why not always use strings? And I will say I use strings a lot. The only issue is sometimes it introduces variability. We ran into this in our early days where you would have one reviewer say human, another reviewer say Homo sapien. Those are the same thing, but in that spreadsheet, in your actual data that you want to analyze, that's something that you have to standardize and equate. You can even see this here. The categorical for what type of study was this was in vitro. The string responded in vitro study. These are the same answer, but were this in one spreadsheet, these would have to be equated. Someone would need to come recognize this and clean up the data. So here's all the information pulled out from the LLM. I am keeping an eye on the clock. Don't worry, Sarah. Um, here's all the information pulled out from the LLM. One thing, again, that is very important is that you have an opportunity to verify it. And so here's that same project. All I've done is filter for this specific article. One thing you'll learn within SysRev is that all of the URLs are actually quite intelligent. And so this particular article is article 103008907. I can search for that article. It brings up just this one article, and that allows me to do a filtered review. So a filtered review is just reviewing whatever list is open on the articles page based on the filters. In this case, it's just one. Filtered review. Okay, this is what we called pre-filled answers. And so here are all of the answers that the auto labeler chose, but now I'm able as a human to review them and affect them. And so it didn't get this wrong, so I won't save it, but let's say it got the toxicity wrong. I, as a human reviewer, am able to come in here and make the correct decision. And so it is a way to allow you on an article basis to review the information, know its original genesis, and change it if necessary. There are some other solutions where you ask a question, it gives you an answer, and it cites itself. This is very different. Again, we can always tie things back to the original article. I can't see the chat. Has any questions popped up? Otherwise, I'll take this one level farther.
Yeah, no questions so far.
Okay. So obviously for evidence-based healthcare, the types of information that we're interested in aren't always high level. They can actually be quite complex. And so I won't dive into this too far, but just to give a bit of a teaser, if someone would like to see how you can use the auto labeler for this type of extraction, more than happy to have the conversation. But so here's a project where we're actually looking at different chemical exposures and what diseases they may or may not cause, and what are the hazard ratios for those causes. And so scrolling down to the bottom, here's a table. And in this table, I've extracted which chemical is being discussed for what endpoint. In this case, it's non-fatty liver disease. What biomarkers were measured to decide whether that person had non-fatty liver disease, how many patients were looked at, how many patients had the liver disease, and what were the hazard ratios. And I've reviewed this, and this is actually 100% correct. And so it is very impressive and powerful what the LLMs are able to extract. This is something we call a group label. So now you're actually pulling out multiple rows for a given article. But the way that it works at the end of the day is the exact same. And so here is my group label, which is just a label of labels for that table that I just showed you. I asked it, what is the chemical? What is the endpoint? What is the sample type? What were the measured biomarkers? So on and so forth. Something that's interesting is once you've developed a good label, you're able to use it again and again and again. So for example, when I first started to use this particular group label, my project was more focused just on liver disease. And so I asked what endpoint is described by the hazard ratio, examples include, and then I gave a bunch of types of liver disease because that's what I was interested in. But then we expanded the project. So now we're just interested in what does this chemical do, not necessarily just within liver disease. There are neurodegenerative diseases. There are things like kidney disease, right? There are lots of other things that PFAS may or may not be doing. I was able to use the same label on all of those articles. And so what that actually looks like is this. And I realize this is just a big spreadsheet with a lot of data. What you can see here is that I have some liver diseases, I have some kidney diseases, some, again, neurodevelopment issues, all using the same extraction form and all being done automatically. Now, what's very important is, again, if there's any article that for some reason I really think I need to look at, perhaps it's the only article that looks at a specific chemical or at a specific endpoint or seems to be in conflict with other articles. Again, this article ID is very important in that I can always go back to my project and look at each article and decide whether or not that extraction was done correctly. And if I do indeed need to affect that extraction, I can always go to that article and do a filtered review. And so now it's not just pre-filling a bunch of simple labels, it's actually pre-filling a table that I can go in and affect. And so again, you're always able to tie every piece of information back to the article from which it was extracted so that you can have that confidence in the extraction because you yourself have reviewed it. Again, that got really busy and complicated at the end, but the larger point is that with time and patience, you can actually develop prompts and labels that allow you to do incredible things. And again, what I really like about that particular label is that I'm able to use it for any human study, for any chemical, for any disease. Now, I have a different label for in vitro studies. I have a different label for in vivo studies, but that's because you're interested in different types of information. When we're talking about the human populations, it tends to be hazard ratios or outcome ratios. When you're looking at individual tests, perhaps it's just lowest level of observed effect, some dose, right? Again, it depends. And really, it comes down to what type of data do you want that informs what labels you want and how you would create and leverage the AI. Hope that wasn't too much. If you have any questions, please feel free to reach out. As you can see, I'm quite passionate about this particular topic and more than happy to discuss further.
Great, thanks B for attending. Thanks everyone for attending, and we will pass along the recording and a link to the slides in email.